In this video, I'd like to look at some examples of how we work with a trapezium. A trapezium has one pair of opposite sides that are parallel. Also, remember that the interior angles of a trapezium always add up to 360 degrees. When working with quadrilaterals, we use internal angles quad as our reason. Let's look at some examples. The sketch below shows quadrilateral ABCD with angles as shown. A, determine the value of x. B, show that AB is parallel to DC. And C, what type of quadrilateral is ABCD? Explain your answer. Let's start with part A, determine the value of x. We have just said that if we add up all the interior angles of a trapezium, we'll get the sum of 360 degrees. And we can use this idea to solve for x. Angle B is 3x plus 20. So we can say 3x plus 20 degrees. Angle C is x. So we can say plus x. Angle A, 3x minus 10. So we say plus 3x minus 10 degrees. And angle D, x plus 30. So say plus x plus 30 degrees. And we make this equal to 360 degrees. We believe the sum of the interior angles of a trapezium is 360 degrees. So as our reason, we put internal angles of a quadrilateral. Now let's add like terms. We have 3x plus x, which is 4x, plus 3x gives us 7x, plus x gives us 8x. Now we have 20 degrees minus 10 gives us 10, plus 30, which gives us 40. So we have 8x plus 40 degrees. And we can make this equal to 360 degrees. Now we need to get 8x by itself. So we can say 8x is equal to, let's move 40 to the right, 360 degrees minus 40 gives us 320 degrees. Now to get x by itself, let's divide both sides by 8. 8x divided by 8 is x. We make this equal to 320 divided by 8 gives us 40 degrees. Now we can move on to part B. Show that AB is parallel to DC. Before we begin, let's quickly make a note up here that x is equal to 40 degrees. Now, in our previous videos, we have said that we use parallel lines to prove angle relationships. But we know we can also use angles to prove that two lines are parallel. We have just found that x is 40 degrees. So let's find the actual sizes of each angle in our diagram. Let's start with angle A. So we can say angle A is equal to 3x minus 10 degrees. We know that x is 40. So we can say 3 multiplied by 40 degrees, close the bracket, minus 10. Now we expand. 3 multiplied by 40 gives us 120 minus 10, which is equal to 110 degrees. This is the size of angle A. So let's make some space. Let's take out 3x minus 10 degrees and write in 110 degrees. Now we can look at angle B. The diagram tells us that angle B is equal to 3x plus 20 degrees. We know that x is 40, so we can say 3 multiplied by 40 degrees plus 20 degrees. Expand our bracket. 3 multiplied by 40 gives us 120 degrees plus 20 degrees, which gives us 140 degrees. This is the size of angle B. So let's make some space. Let's take 3x plus 20 out of our diagram and write in 140 degrees. The angle of C is simply x, and we know that x is 40. So let's take the x out of the diagram and write in 40 degrees. Finally, let's look at angle D. We can see that angle D is equal to x plus 30 degrees. X is 40 degrees, so we say 40 plus 30 degrees, which gives us 70 degrees. Now we can make some space. Let's take out x plus 30 and write in 70 degrees for angle D. Now the question asks us to prove that side AB is parallel to side DC. So let's make these sides blue. There are two transversal lines cutting our parallel lines, AD and BC. So let's focus on AD and make it purple. Angle A and angle D both lie between the parallel lines on the same side of the transversal line, so they are co-interior angles. And we know from our previous videos that if two lines are parallel, then co-interior angles are supplementary. So in this case, if we can show the two co-interior angles are supplementary, we can then prove the two lines are parallel. If two angles are supplementary, they add up to 180 degrees. So we can say angle A plus angle D is equal to 110 degrees plus 70 degrees, which is 180 degrees. These co-interior angles are supplementary, which means that AB is parallel to CD. And as our reason, we say co-interior angles are supplementary. Now let's make our diagram black again, and we can put an arrow on AB and an arrow on CD to show that these sides are parallel. And now we can move on to part C. What type of quadrilateral is ABCD? Explain your answer. The only characteristic this quadrilateral has is one pair of parallel sides. So we can say ABCD is a trapezium because it has one pair of opposite sides that are parallel. Let's do another example. The sketch below shows quadrilateral EFGH with the angles shown. Part A, determine the value of P. And part B, what type of quadrilateral is EFGH? Motivate your answer. Let's start with part A. Determine the value of P. Now, just like we did in the previous question, we can add up all the interior angles of this quadrilateral in order to solve for P. So we can see that angle E is P minus 10. So we say P minus 10 degrees. Angle F, 3P minus 50. So we say plus 3P minus 50 degrees. Angle G, 2P minus 20. So we say plus 2P minus 20 degrees. And angle H, P plus 20. So we say plus P plus 20 degrees. And we make this equal to 360 degrees. Again, we know that the sum of the interior angles will be 360 degrees because they are the interior angles of a quadrilateral. So we make this our reason. Now we can add like terms. We have P plus 3P, which gives us 4P, plus P gives us 5P, plus 2P, which gives us 7P. Now we have negative 10 minus 50 gives us negative 60, plus 20 gives us negative 40, minus 20 takes us back to negative 60. So we say minus 60 degrees is equal to 360 degrees. Now, to get our p term by itself, we can say 7p is equal to, let's move negative 60 across. We get 360 plus 60, which gives us 420 degrees. Finally, to get p by itself, let's divide both sides by 7. 7p divided by 7 leaves us with p is equal to 420 divided by 7. We know 42 divided by 7 is 6. So p must be 60 degrees. Now we can move on to part B. What type of quadrilateral is EFGH? Motivate your answer. Let's quickly make a note up here that P is equal to 60 degrees. To determine what type of quadrilateral this is, we need to find some characteristics about it. We don't have the lengths of any sides, but we do know that P is 60 degrees. In questions like this, your answer from one part will help you find the answer to the next. Let's use the value of P to find the size of each interior angle. Let's start with angle E, and we can say angle E is equal to P minus 10 degrees. We know that P is 60, so we can say 60 degrees minus 10 degrees, which gives us 50 degrees. This is the size of angle E. So let's make some space. Let's take out P minus 10 degrees, and we can fill in 50 degrees. Now let's look at angle F. You can say angle F is equal to 3P minus 50 degrees. P is 60, so we get 3 multiplied by 60 degrees minus 50 degrees. Let's expand our bracket. 3 multiplied by 60 gives us 180 degrees minus 50 degrees, which gives us a total of 130 degrees. Angle F is 130 degrees. So let's make some space. Let's take out 3P minus 50 degrees, and we can write in 130 degrees. Now let's look for angle G. We can see that angle G is equal to 2P minus 20 degrees. P is 60, so this becomes 2 multiplied by 60 degrees minus 20 degrees. 2 multiplied by 60 gives us 120 degrees minus 20 degrees, which leaves us with 100 degrees. Now we can make some space. Let's take out 2P minus 20 degrees and fill in 100 degrees. Now let's look for angle H. So we can say angle H is equal to P plus 20 degrees. P is 60, so we get 60 degrees plus 20 degrees, which gives us a total of 80 degrees. Let's make some space. Let's take P plus 20 out of the diagram, and we can fill in 80 degrees. Now we can consider the whole diagram. A diagram like this may not be to scale, but it will give us a general idea of what we're working with. Straight away, we can see that there is no way that side EF is parallel to side HG, but side EH might be parallel to FG. So let's make these sides blue. These lines are cut by two transversal lines, EF and GH. Let's look at EF. and we can make it purple. Now, if EH is parallel to FG, then co-interior angles will be supplementary. Angle E and angle F both sit between the parallel lines on the same side of the transversal line. So let's see if these angles add up to 180 degrees. So we can say angle E plus angle F is equal to, E is 50, so we say 50 degrees, plus F 130 degrees, which gives us a total of 180 degrees. These angles are supplementary, which means that EH is parallel to FG. Don't forget to give your reasons that co-interior angles are supplementary. This is the only characteristic we have, so we can conclude that EFGH is a trapezium because one pair of opposite sides are parallel.